Hello everyone, I am Mridul Sungra. I'm here to present a specification and design proposal for my project titled Deep Learning for Robotic Grasping. Coming to the project description, different literature propose slightly different words to define grasping. In a summarized way, grasping can be defined as a collection of fingers exerting forces on an object, which means we are trying to hold the object. The application of grasping are basically everywhere. It ranges from the tedious warehouse jobs of picking, packing, and sorting objects to trivial household jobs of cleaning and organizing, and even hazardous jobs like material handling in nuclear power plants. For such jobs, literature suggests using robots which can work tirelessly without degradation in performance, even in areas which are dangerous to human health. Our project is an attempt in that direction. We propose a solution for robotic grasping using deep learning methods. We break down the project in 3 steps and we shall then propose the method to solve this problem during this presentation. The input shall be an image captured using a webcam, which then shall be processed to detect objects using object instance segmentation techniques. Followed by that, evaluation of principal axis for the detected object shall be attempted, and that shall be used for assessing the grasping location. Finally, implementing the result on a real physical robot hardware which shall grasp the detected object along the identified axis shall be attempted. The aim of this project is to develop a novel deep learning based vision method for autonomous grasping applications. Objectives we have set forth for ourselves, which we'll attempt to achieve during the course of this project, are: first, we'll use an object instance segmentation technique to detect objects in a scene captured using a webcam. Second, we'll attempt to extract the principal axis for each object detected in the first objective. Next, we'll apply the detected result to a actual physical robotic hardware. In our case, we'll use a UR5 robotic hand. And last but not least, we'll test and evaluate the detection and grasping algorithm. Next, I will mention a brief literature review related to the topic of deep learning for robotic grasping. The literature mentions various grasping approaches which has evolved from analytical methods used in previous century to data-driven and even object-centric methods in the recent years. This project is categorized as an end-to-end learning-based data-driven grasping method. The grasping components are mentioned in various in literature, and it includes grasp detection to identify the grasping pose. Grasp detection can be attempted using various techniques, including computer vision based algorithm, which we will use in our project. Grasp planning to determine the path and parameter of the end effector. Planning also include computation to achieve required dexterity, equilibrium, stability, and dynamic behavior of the grasp. Last is the control system to regulate joints, ensuring smooth traverse. We have also surveyed various quality metrics which include grasp closure, which specify if the grasp is able to resist any external disturbing wrench. Another metric is grasp wrench space, which specify all the possible wrenches that could be imposed through contact points of the grasp. Another metric is grasping post detection, which is a CNN based quality metrics for a robotic grasp. Coming to the development and implementation of the project. As mentioned in the objectives, we plan to take as input an image captured using webcam. This image shall be processed for object detection using object instance segmentation technique of mask RCNN. We plan to use pre-trained model which is available in PyTorch framework. We shall then attempt to evaluate the grasping access for the detected object using principal component analysis for each object detected by mask RCNN. For implementing PCA, we plan to use OpenCV library, which provide functions to calculate mean, eigenvalue, and eigenvectors. We'll then assemble the software part with the hardware and implement the grasping using MoveIt on a UR5 robotic arm. Next, I'll mention about the testing part for our project. We plan to conduct several tests during the course of this project. To test the object detection module, we plan to run the detection algorithm under varying surrounding conditions like lighting changes and introducing clutter in the background. Next, we plan to use a variety of objects using different shapes, sizes, and textures and material, which will establish the robustness of the system. We also plan to vary the orientation of the object such that the camera view the same object from different angles. With this, we'll be able to assess the adaptability and the robustness of the system. We plan to evaluate our grasp using the following evaluation metrics. First, the object detection accuracy shall be evaluated by measuring the fraction of objects correctly identified by the detection algorithm. Second, success rate shall be measured by the fraction of successful grasp out of the total number of grasps attempted. Third, grasp stability shall be assessed by observing the grasp in event of external perturbation to the object. Last but not least, execution time shall also be measured, which include the time to plan and execute the grasp. The execution time will tell about the efficiency of the system. I'm going to present the project plan as a Gantt chart showing the task and milestone that I hope to achieve to successfully complete this project. This presentation shall complete the project specification and the design proposal part. Next, currently I am working on the application of mask RCNN for object instance segmentation. Next, I will use webcam as an input for the mask RCNN, which shall be finished by the next week. By the end of July, I shall finish the part to extract the principal access on the detected object, and next month I shall work in the smart lab of the Digital Innovation Facility to implement the project on the UR5 robot. This shall be completed by the end of August, and it shall be followed by preparation of final presentation and dissertation. To summarize, I have presented the specification and the proposed design for my project. I have presented the project description, a brief literature review, the testing and evaluation plan, and the project plan with the schedule to complete the project. Thank you.